of our vocabulary from yesterday. Corresponding angles are like angles 1 and 5. 1 and 5 are corresponding angles. 2 and 6, they're called corresponding because they're in the same position, but they're on different lines. 3 and 7, and 4 and 8. Alternate interior angles have to alternate the transversal line, but they have to be in between your two other lines. So 3 and 6 would be a good example, or 4 and 5. Alternate exterior angles are like 1 and 8. They have to alternate the transversal, but they're outside of your two other lines. Or 2 and 7 are both outside, they're exterior, and they alternate the transversal. Consecutive interior, 3 and 5, that means they're in a row and they have to be interior, so in between your two lines. The other set of consecutive interior would be 4 and 6. Consecutive exterior would be like 1 and 7, or 2 and 8. Those are consecutive exterior. Don't forget about your vertical angles and your linear pairs. So if you're looking for the equation of a line that's parallel, it has to have the same slope. So I had to take my equation over here, 2x minus 3y equals 7, solve it for slope-intercept form. When I did that, I got a slope of 2/3. So the slope we're going to use is going to be 2/3. And it goes through this point, 4, 2. That's going to be my x1, y1. So if I want the equation of a line that's parallel to that line, so it has 2/3 slope, and it goes through the point 4, 2, I use the point slope form and solve. Okay, so parallel lines cut by transversal. What happens when the two lines cut by the transversal end up being parallel? Okay, let's draw a line anywhere in Desmos, okay? I'm going to put a point out here anywhere you want. If I want to construct a line that's parallel to the blue line but goes through that point, I come down here to look at parallel lines. It says choose a line to set the slope. Well, we want it parallel to this line, so we're going to choose that line. And it says choose a point to set location. So let's choose this point. So now we should have two parallel lines. I'm going to hide these points because we don't need them, so just go and click on them and hide them. Let's draw in a transversal line. Transversal line is a line that intersects two or more lines. When I draw my transversal, I'm going to change it to red. This is my transversal. And come over here, take this point away and hide it. Okay. So let's go measure our angles. I'm going to measure this angle. Let's measure the angle that's vertical to it. We should get 37 degrees because they're both vertical angles. Now let's come down here and measure this angle. How many degrees do you think it will be? It's also 37 degrees. Let's measure the other vertical angle. 37 degrees. So all four of those vertical angles are 37 degrees. Let's go hide all these points. Okay. If I draw a point here and make this point orange, I can also change this in here to be orange. In fact, I don't even need this point. Let's just come down here and change this also to orange. What type of angles are those two orange angles? Those are corresponding angles, and if you look, corresponding angles are always going to be congruent. Let me turn this one green. Come down here and turn this one green now. Turn this one back to being black. Okay. Look at these two green angles now. What type of angles are those? Those are alternate interior angles, and alternate interior angles will always be congruent to each other when the lines are parallel. Come over here, look at 37 degrees and 37 degrees, the two black angles. Well, those two angles are alternate exterior angles, and alternate exterior angles are going to be congruent. Now let's measure these other ones. Do you know how many degrees the last four angles will be? Why are these last four angles 143? Well, they have to be supplementary to the other vertical angles that we did. So 37 plus 143, that equals 180. Again, I'm going to go hide all these points. You don't have to hide them, it just makes our picture look better. Okay, so the only ones we haven't talked about were consecutive interior and consecutive exterior. So consecutive interior would be like this 30, I'll change it blue, 37 degrees, and this 143 down here. Those are called consecutive interior because they're in between the two parallel lines, but they're on the same side of the transversal. What do you notice about the consecutive interior angles? They add up to be 180 degrees. Same thing on the other side, consecutive interior. Same thing, they add up to be 180. What about consecutive exterior? Consecutive exterior angles also add up to be 180 degrees. Let's take a screenshot of this. Copy to clipboard. Let's paste our picture here, Control V. You can make it as big or as small as you want. Okay, so we have a few things going on here. we have this thing called the corresponding angle postulate. The reason why we call it a postulate is because we assume it to be true. Euclid said this will always be true. So the corresponding angle postulate says if parallel lines so the lines have to be parallel, are cut by transversal, then corresponding angles will always be, we said corresponding angles are going to be congruent. So he came up with this postulate. This is something we assume to be true. Well, after he came up with this postulate, he came up with a bunch of theorems or theories. What did he have to do to these theorems? He had to prove that all of these theorems were true. So the first theorem I want to look at is called the alternate interior angle theorem. If you have parallel lines cut by transversal, we said alternate interior angles are going to be congruent. And that means that if we had parallel lines cut by transversal, alternate exterior angles will also be congruent. And when we did our little exploration, consecutive interior angles, so if the lines are parallel, cut by transversal, consecutive interior angles are going to be, we said supplementary this time. And consecutive exterior angles, if the lines are parallel, consecutive exterior angles will also be supplementary.